Bismillahirrahmanirrahim. Architecture of data warehouse. So, uh, architecture is basically the proper arrangement of components. You build a data warehouse with software and hardware to suit the requirements of your organization. You arrange these building blocks or components in a certain way for maximum benefit. So there can be multiple tiers in it. First is the source data component. Here there are many sources, like the sources can be semi-structured. Data can be taken from the web also, from archived files as well, and from operational databases. Here, then after that, data will be moved to a separate staging area. There should be an arrow like this, and in this staging area, the actual transformation of the data takes place before loading it into the data warehouse. So there is metadata attached with it. Metadata is the data about data. We will discuss in detail about metadata in next slides. And there are various data marts as well. So we will discuss about data marts also in today's lecture. Then is the OLAP server tiers. So after when the data warehouse is constructed, uh, data should be presented in summarized form in MOLAP queue. So this is the multi-dimensional view of the data. Here in each in this queue, aggregates will be placed to retrieve the information quickly. And data can be in ROLAP form as well. ROLAP means relational OLAP. So then is the information delivery component. Here the query reporting and various analysis on the data will take place and data can be fed to data mining applications or tools to get the insight on trends or patterns from the data. Now I am going to discuss these components in next slides. Source data component, which is the first component. So source data coming into the data warehouse may be grouped into four broad categories. First is the production data. So this category of data comes from various operational systems of the enterprise. So these normally include financial systems, manufacturing systems, and customer relationship management systems. So based on the information requirements in the data warehouse, you choose segments of data from these different operational systems. So while dealing with the data, you come across many variations in the data format. So you have to convert it into a consistent one before loading it into data warehouse. Next is the internal data. So in every organization, keep their private spreadsheets, documents, customer profiles, and sometimes even departmental databases. So this is the internal data, parts of which can be useful in the data warehouse. So there is a requirement to bring the internal data as well. In every operational system, you periodically take the old data and store it in archived files. So the circumstances in your organization dictate how often and which portions of the operational databases are archived to a separate storage area. So many different methods of archiving exist. There are many archived methods. At the first stage, recent data is archived to a separate archival database. At the second stage, the older data is archived to flat files on disk storage. So there are various methods for it. So then is the external data. So most executives depend on data from external sources for high percentage of the information they use. So for example, the data warehouse of a car rental company contains data on the current production schedules of the leading automobile manufacturers. So this external data in the data warehouse helps the car rental company plan for its fleet management. So the purposes served by such external data sources cannot be fulfilled by the data available within your organization itself. In short, there can be a requirement that you have to take from the data, you have to take data from some source that is outside your organization. So that sources we call external data sources. So next is the data staging component. So data staging provides a place and an area with a set of functions to clean, change, combine, convert, deduplicate, and prepare source data for storage and use in the data warehouse. As I told you before, when we were on the figure of the architecture, that there is a separate staging area where you place the data to perform transformation on it. So the extracted data coming from several disparate sources needs to be changed, converted and made ready in a format that is suitable to be stored for curing and analysis. So extraction, transformation and preparation for loading take place in a staging area. Data storage component. The data storage for data warehouse is separate repository where you store the data, historical data. So in the data repository of data warehouse, you need to keep large volumes of historical data for analysis. Further, you have to keep the data in data warehouse in some structure which is suitable for analysis. So the data warehouse employ relational database management systems or many data warehouses also employ multi-dimensional databases as well. Means data extracted from the data warehouse storage is then aggregated in many ways. Like I shown you OLAP servers uh, here where uh, there is a MOLAP. So in MOLAP, data is in aggregated form. So and the summary data is kept in that multi-dimensional database which you call MOLAP. Then is the information delivery component. So basically, who are the users that need information from the data warehouse? So in order to provide information to wide community of users, the information delivery component includes different methods of information delivery, like ad hoc reports, like complex queries, like analysis. So the figure shows the different information delivery methods. So ad hoc reports are predefined reports primarily meant for novice or casual users who don't know much about the IT. Provision for complex queries, multidimensional uh, analysis, and statistical analysis cater to the need of business analysts. Information fed into executive information system is meant for senior executives and high level managers. So some data warehouses also provide data to data mining applications. Data mining applications are knowledge discovery systems where the mining algorithms helps you discover trends and patterns from the usage of your data. Another element in the architecture diagram was data mart. So data mart is focused on a single functional area of an organization and contains a subset of data stored in a data warehouse or from data warehouse. So data mart helps to enhance user performance, user response time due to reduction in the volume of data. So what are the reason? What are the reasons to build data mart? So if a particular department wants to see the query results much faster instead of scanning huge data warehouse data, or if a department wants data to be built on some other hardware or software platforms, or if a department wants data to be designed in a manner that is suitable for its own tools. So there can be other reasons as well. So the data mart can be constructed using top-down approach or using bottom-up approach. So in top-down approach, data warehouse is built first and then the data marts are built in top-down approach. So the main advantage is that all the information is available at once at the central location. The disadvantage can be that it becomes a very big project which should be handled by a specialist, and the cost and time involved will also be high. So another approach to build data mart is bottom up. Bottom up approach, data marts are built first and then data warehouse is built. So data marts can be built very quickly. Hence the results are seen much faster. So there can be different types of data marts are there, like dependent, independent, and hybrid. First is the dependent data mart. So in dependent data mart, data is sourced from the existing data warehouse itself. So this is obviously top-down approach in which the data warehouse is built first, because the portion of restructured data into data mart is extracted from the centralized data warehouse. So in short, dependent data mart is the one in which the source of input is the centralized data warehouse. Next is the independent data mart. So independent data are stand-alone systems where data is extracted, transformed, and loaded from external or internal data sources. These can be operational systems, these can be archived files or external sources. Independent data mart is best suitable for small departments in an organization. They are basically easy to design and maintain. Then is the hybrid. In hybrid data mart, data is integrated from both the central data warehouse as well as other operational systems. So here the hybrid approach is followed, in which the source of input can be uh, operational systems as well as data warehouse as well as other data marts as well. So now the advantages of data mart. Data mart contain a subset of organization-wide data. So it contains uh, usually contains data about a single subject, while in data warehouse the data can be of multiple subjects. So this data is valuable to some specific group of people or to some specific department of an organization. It is cost effective alternate to the data warehouse. So it serves the need of a particular department in less cost, which can take high cost. So data mart allows faster access because it is less in size as compared to the whole data warehouse. So it allows faster access. So it is easy to use. It is specifically designed for the needs of its users. So data mart needs less implementation time because it is smaller in size as compared to data warehouse. So as you only need to concentrate only the subset or one subject of data which a particular department wants to investigate. Next, the disadvantages? So many times enterprise creates too many disparate unrelated data marts without much benefit. So unwanted data marts basically have been created, are tough to maintain. So data marts are meant for small business needs or for some particular departmental needs. Increasing the size of the data mart will decrease its performance. So data mart cannot provide company-wide data analysis as their data set is limited to some particular subject or to a particular department of an organization. So it will not provide you, cannot provide you company-wide analysis of the data. Next element in architecture is metadata. So metadata is simply defined as data about data. When you keep information about the data of the data warehouse that you keep in a metadata repository. So for example, the index of book serves as a metadata for the contents in the book. So metadata is considered roadmap to a data warehouse. So through the metadata, you can understand the data of the data warehouse. It acts as a directory. This directory helps the decision support system to locate the contents of the data warehouse. So now there are basically three types of metadata. First is the operational metadata. So data for the data warehouse, as you know, comes from several operational systems of the enterprise. Now the source system contain different data structures. So the data elements selected for the data warehouse have various field lengths and data types. So in selecting data from the source systems for data warehouse, there may be a requirement to split the records. There is a requirement that all the records, you may not feel that all the records are necessary to be bring into data warehouse. So you may need splitting, or you need to combine parts of records from one operational system with records from other operational system. So the operational systems deal with multiple coding schemes and field lengths. So when you deliver information to end user, you must be able to tie that back to the original source data set. That if some information is there in the data warehouse, what is the source of the information? Either it comes from this information system, either it comes from information system 2, either it comes from information system 3. And from what tables what are the source of information? So what columns are taken from this operational system, and they are combined with what columns from this operational system. So when you deliver information to end user from the data warehouse, you must be able to tie that back to the original data set. So operational metadata contains all this information, fine, about the operational data sources. Next is the extraction and transformation metadata is the second type. So extraction and transformation metadata contains data about the extraction of data from the source systems. That word source systems are involved. What is the extraction frequency from the source systems? After how much time you are extracting data from the source system? Either you are extracting on monthly basis, or
After 15 days, what is the extraction frequency, how much records you are extracting, what methods you have used for extraction, for extracting some particular data, what are the business rules you applied. So all this information will be saved in the extraction and transformation metadata. So contains information. So this category of metadata contains information about all the data transformations, what type of transformation you have applied on the data uh, before bringing it into the warehouse. So that takes place in the data staging area. So data staging area I have explained earlier. So third category is end user metadata. So basically, end user metadata is considered the navigational map of the data warehouse. How the end user gets information from the data warehouse. So how he navigate uh, through the data warehouse, how he gets the information. So it enables the end user to find information from the data warehouse. It also keeps track which users uh, used which information from the data warehouse. So these are the three types of metadata. So metadata has a very important significance in data warehouse. It basically acts as a glue that connects all data parts of the data warehouse. It provides information about the contents and structure of the data to the developers. So it opens the door to end users also and make the content recognizable in their terms. So this is about metadata. So last is the summary of the lecture. So we discussed the architecture of data warehouse, that what are the components involved in the architecture and how they relate with each other. We discussed the source component, that what are the source systems that input data to the warehouse, what is the staging area, what is ETL. Then after data source component is the staging area, then data storage component, how the data is stored in the data warehouse. After that, there is a tier for OLAP servers. How after the data warehouse is built, we need some tool for analysis with the warehouse data. So basically, MoLab presents information in aggregated or summarized form to the end user, because in analysis usually the decision makers require summary or bigger picture for analysis. After that, we discussed the information delivery component, what are the various methods in that, and what are the users involved. So after that, we discussed uh, data mart in the data warehouse. What is data mart? What are the types of data mart? What is the significance or importance of data mart? What are the approaches to build data mart? Either we have to follow top down approach or bottom up approach. So there are various types of data marts, like mm, uh, uh, like dependent data mart, independent data mart, and hybrid data mart. So after that, we have discussed another element in the architecture, which is metadata. So metadata is data about data. We whatever data we place in the data warehouse, the information related uh, to that data will be stored in the metadata repository. So basically, through metadata, we understand the data in the data warehouse. There are various types of metadata like operational data, extraction and transformation metadata, and end user metadata.